Welcome to another magnificent conversation. Today we're going to continue on with exponent rules, but we're going to cover some problems that might look familiar as you're practicing for the SAT and how those exponent rules show up in questions. So first we're going to start with a few basic examples, and then I'll give a more in-depth example of what you might see while you're practicing for the SAT. So this example wants you to rewrite 3 times 2 to the x plus 1 in the form a times b to the x. So right now we have 3 times 2 to the x plus 1. To rewrite it in the form a times b to the x, the only thing that can be in our exponent is x. Currently, we have x plus 1. So I think back on my exponent rules. If I have two things that are added in my exponents, that means we're here with this rule. Two things that had the same base were being multiplied, so the exponents were added. So 3 times 2 to the x times 2 to the first. So we're essentially moving backwards in this example. Well, 2 to the first is just 2. I'm going to move it in the front so I can multiply it with the 3 times 2 to the x. So this is 6 times 2 to the x, which is now in the form a times b to the x, where a equals 6 and b equals 2. Okay, our second example, 2 over 3 times 1 over 2 to the x minus 1 can be rewritten in the form a times b to the x. What is the value of a? So we start with 2 over 3 times 1 over 2 to the x minus 1. Again, we need this in the form a times b to the x, which means the only thing that can be in the exponent is an x. And right now, we have x minus 1. Which looks like this rule here. Okay? So that means we have 2 over 3 times 1 over 2 to the x all over 1 over 2 to the first, because that's our rule. If I was subtracting, then I had two things I was dividing with the same base. Well, we know 1 over 2 in the denominator means that we need to take its reciprocal. So we really have 2 over 3 times 2 over 1. Again, the 1/2 in the denominator is where the 2 over 1 comes from, times 1 over 2 to the x. And this becomes 4 over 3, because we multiply fractions straight across, times 1 over 2 to the x. Now we're in the form a times b to the x, where a is equal to 4 over 3. Example 3, rewrite 3 times 1.45 to the x over 2 in the form a times b to the x. So this one is somewhat similar. We start with 3 times 1.45 to the x over 2. And we want to rewrite as a times b to the x. And again, the problem is our exponent is not alone. It's x divided by 2 instead of just x. Well, I'm going to use a little finesse and remember x over 2 is the same thing as 1/2 times x. Well, 1/2 times x means I have two things in my exponent multiplied. So that means that was our power to a power rule. Okay? What that tells me is I can rearrange these so I have 1.45 to the 1/2 raised to the x power. And if I were to go forward, I know I would multiply 1/2 times x, and I'd be right back where I started. Well, because all of your SAT problems are calculator problems, 1.45 to the 1/2, if you're to put that in your calculator, is 1.20. And then we're just left to the x. So now we're in the form a times b to the x, where a equals 3 and b equals 1.20.
What did the Earth say to the asteroid?
What?
Give me space.
Example 4, we have 1.25 times 1.3 to the 5x can be rewritten in the form a times b to the x. What is the value of b? Okay, so we'll start with the form we're currently in. And we know we need to rewrite as a times b to the x. Again, the 5x is the issue because the only thing in the exponent should be x. So again, this is still our power to a power rule. So we're going to use our finesse and rewrite 1.25. And then this is going to be 1.3 to the 5th raised to the x. Again, all of our problems are calculator problems. So we can put 1.3 to the 5th in our calculator and we get 3.713 and then raised to the x with a and b to the x. So now we know a is 1.25 and b is 3.713. Example 5 looks a little bit more like what you'll actually see if you're taking the SAT. A function f is defined, f of x equals 153 times 4 to the x. If g of x is equal to f of x minus 2, what equation defines g of x? So this question has a lot of layers. So we're given this exponential function here, but then we're giving what we call a transformation. So g is a transformation of f. And in a lot of detail, it's f moved 2 units to the right. You can find out more about transformations in the transformation video that I will create. When we have a transformation, that means we're going to evaluate that into our function. So g of x, which we were told is equal to f of x minus 2, means evaluate x minus 2 into f. So that's going to be 153 times 4 to the x minus 2. So now that we've evaluated x minus 2 into f, we just need to simplify. We know for an exponential In our exponent, we should only have an x. And right now we have x minus 2. And we just practiced that that is this rule here. So right now we have 153 times 4 to the x divided by 4 squared, because we are essentially undoing the quotient rule for exponents. Well, that's great because we can break this apart. 153 times 1 over 16, 4 squared is 16. I'm going to rewrite it like that. Well, these two are numbers, so we can simplify them together. 153 over 16 times 4 to the x. And again, all problems are calculator problems, so you would want to put 153 over 16, and you get 9.5625 times 4 to the x, which is what g of x is defined as. A function f is defined as f of x equals 3 over 2 times b to the x. If g of x is equal to f of x over 3, what equation defines g of x? So again, this is a transformation problem. So g of x is defined by evaluating x over 3 into f. So 3 over 2 times 5 to the x over 3. Similar to examples we've done, to define g of x, we know we should only have x in our exponent. Will be the answer choices that you're looking for. So we have x over 3. So that's going to be our power to a power rule. So we're going to rewrite 3 over 2. And then this is 5 to the 1 over 3 times x. So you can clearly see that it's two things multiplied in the exponent, which means originally it could have been 5 to the 1/3 to the x. Because of our power to a power rule, we're allowed to rewrite it like that. Then we would want to put 5 to the 1 over 3 in the calculator. And we get 1.7100 to the x. So now g is defined as an exponential, where a would be 3 over 2 and b would be 1.7100. So g of x is defined as 3 over 2 times 1.7100 to the x.